All right, so type 1 and type 2 errors are kind of bad on both sides. You don't really want a lot of either one of them. And you don't want it in the legal system, you don't want it anywhere really. But nevertheless, they're kind of unavoidable because if you're making decisions, then automatically there's a chance that you're making the wrong decision. So what we do as mathematicians, the first thing we did is assign letters to both of them. So alpha is the probability of making a type 1 error, and beta, that's a little b with a tail on it, that's beta, is the probability of making a type 2 error. When we in statistics, when we refer to the level of significance, we're referring to alpha. Beta is actually a little bit trickier to work with, and we're not going to do much with it at this point. Suffice to say that it's part of something called the power of the test, and who knows, maybe I'll make a video for that eventually. But for right now, all you need to know is that it's the probability of making a type 2 error, and that's not a good thing. So then the question becomes, well, if they're both bad, why don't we just set them to 0? Okay, well, there's a couple problems with that. First, just logically speaking, we can never make both alpha and beta 0 because that would imply that we're 100% sure, which we never will be. Even if you think about the rigged die example I used, it's not like I'm 100% sure that that die was rigged, right? Maybe he just lied. Maybe he just got really lucky and got all of them to be 5s. Who knows, right? If we try to lower alpha to 0, right? So if we try to do that, what's going to happen? Well, if you want to make it so that you never, 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 never put away somebody who didn't do the crime, then what's going to happen over here? If you're letting all sorts of people go because you don't want to wrongfully convict anybody, then you're going to end up letting go a lot of people that were actually guilty, right? So if you try to lower alpha to 0, beta grows, right? To way too high a level. By the same token, if we try to lower beta to 0, alpha grows to too high level. If you're like, oh, I'll never I'll never let guilty people go free, I'll make them sure that they suffer, blah, blah, blah. If you're going to put everybody away, then that means invariably you're going to be putting away people that are innocent. Okay? It's the flip side to the tough on crime thing, because everybody says, oh, I want you to be tough on crime. But the problem is that the more tough on crime you are, then the more wrongful convictions you're going to be having. Okay, they go hand in hand. All right, now that we're through all of that, let's talk about this just a little bit. So a group of researchers studied the effect of global environmental change on grazing lands. Their article reported the results of 171 different hypothesis tests. Of these tests, 4 were determined to be not significant, not statistically significant. Note that alpha is 0.05 and beta is 0.03 for each of these tests. For each of these tests, what is the probability of making a type 2 error? Well, beta is the probability of making a type 2 error. So it would be 0.03, right? Okay, let's remind ourselves, what is beta? Beta is the probability of making a type 2 error. Okay? Meaning you do not reject when you should have. You thought, hold on one second. There we go, I wrote it out. It's the probability that you're going to find a test to be not significant, but you should have. Because something insignificant is going on. If that's the case, then how many do we expect? Well, 0.03 times 171, which is, hold on, there we go, 5.13 tests. So based on this information, what would we say about those 4 not significant tests that we found? Those 4 tests are most likely false negative tests, because they're under 5.13. It had been 14 false or negative tests, then that would have been something.